Now let us do another good numerical. Such numericals, of course, came before in few years back came in JEE main examination. The time duration is such, so you can expect such questions in GATE examination also. The solution to engineering mechanics by Professor Timoshenko and Professor D.H. Young from Stanford. The book has been very popular for last 80 years. Now problem set 2.5, solution to 2.69. Here we have a ladder resting against a wall and a person is climbing the wall and is at the middle of the ladder. Now let us see the conditions of equilibrium and the reaction forces. A 7.5 Newton man. This is the weight of a man. The man is standing exactly at the middle of the ladder. Stands on the middle of the rung. Now what is a rung? It will tell you of 2.5 Newton ladder. The weight of the ladder is 2.5 Newton as shown in figure. Assuming the smooth wall, a smooth wall at B, means there is no force of friction, and there is a stop here at A which prevents this ladder from slipping like this. The ladder does not slip like this due to this arrangement called a stop. Find the reactions at point A and point B. Now what is a rung? A rung is one of the horizontal steps in a ladder. In a ladder, there are horizontal steps. While climbing, you can put your feet on the steps, or you can hold one of the steps and climb up and can climb down. So a rung is one of the horizontal steps of a ladder where you can put your foot or hand while climbing up or down. Now look, the man, this ladder, its weight is acting from the center of mass, which is exactly at the geometrical center, acting vertically downward. And the man is also standing at the same point. So his weight is also acting from the same point vertically downward. Means both the weights, the weight of the ladder and the weight of the man, they are in the same line of action. So it will be added. So let W1 is the weight of the man. This is given. The man is at the middle of the ladder, means the same point from where the weight of the ladder is acting vertically downward, and the weight of the ladder is given as 2.5 Newton. So the total weight W acting downward from the point C will be W1 plus W2. So that is equal to W1 plus W2, that is equal to 890 Newton is acting from the center of the ladder vertically downward, the total weight. Now I have again redrawn a diagram for you. If you look at it here, the same diagram, this is your ladder. This is the center of mass of the ladder being the center of the ladder, midpoint. The man is also here. So both the weights are acting downward, that is W1 plus W2, which is equal to 890 Newton. Now, so if you extend this line, here the reaction force from the wall here, the reaction force RB is pointing to this side, which I have shown it here, the reaction force pointing to this side. The reaction force RB and W, they have this common point of intersection, this common point, this RB and this W, they have this common point of intersection. So RB is one force and W is one force. So the resultant of RB and W will be pointing to this side. If you construct a parallelogram with taking RB as one side and W as one side, the resultant of RB and W will be pointing to this side. And the reaction from here, the point A, if it is exactly opposite to the resultant of RB and W, then the condition of equilibrium will be established. So RA has to pass through the same point T. Means RA is not along the ladder. It is away from that. It is away from that, right? So, now the question is, let this angle is equal to alpha. Let this whole angle. This angle is alpha. Now look, since C is the midpoint of the side AB, and and from midpoint of the side of the triangle ABD, from the midpoint of the side AB of the triangle ABD, this is a line parallel to the side BD. So at this point, AD will be equally divided, means from A to F will be from F to D. So that is what I have argued here. Since BD is parallel to CF, C is the midpoint of AB, therefore AF is equal to FD is equal to half of AD. From A to D is given as 1.8 meter. So half of that is 1.8 by 2. Now let angle EAF, this angle is alpha. So tan alpha will be EF over AF, and EF has the same length as the length BD, so that is equal to BD over AF. Now put the values. Tan alpha, put the value of BD 3.6 millimeter, 3.6 meter. So 3.6 meter over 1.8 by 2 meter cancels, 2 comes to the numerator. 3.6 into 2 over 1.8, it's 4. So your alpha is equal to tan inverse of 4. That comes out to be 75 degree, 57 minutes, 49.52 seconds of arc in a scientific calculator. Now let us draw the free body diagram at point E. So for that, what you have to do, this RB is passing through the point E towards this side. You can extend this RA parallel to itself along the same line of action and sew it here, RA. Now, and W, the line of action of W, you can shift it here and sew it here as W. Now, here, if you draw this as x-axis and this as y-axis, then this angle will also be alpha. How this will be alpha? This line is parallel to this line, and this is the transversal. Since this angle is alpha, this angle is also alpha, the corresponding angle. So this is your x-axis, this is your y-axis. So the free body diagram at this point E, I have redrawn for you in a different piece of paper, and I have explained how this angle is alpha. This is RA, this is your RB, the reaction force from the wall, this is your W. Now again the same argument. The resultant of any two, means the resultant of this and this, which will be to this side, will be equal and opposite to RA for the condition of equilibrium. Or if you consider the resultant of RA and W by constructing a parallelogram like this, then the resultant of RA and W should be equal and opposite to RB. Similarly, if you construct a parallelogram taking RB and RA as the two adjacent sides at this point and construct a parallelogram like this, construct a parallelogram, then the resultant of RA and RB, which will be to this side, must be equal and opposite to W to establish the condition of equilibrium. But we are not required to find the resultant. We'll split the vectors into components and make the sigma x is equal to 0 and sigma y is equal to 0. So let us first begin with sigma y is equal to 0. This W is already along negative y-axis, so if you drop a perpendicular from here on positive y-axis, this part will be your RA times sine alpha. And RA sine alpha is exactly opposite to W. So if their values are equal, they will cancel. So RA sine alpha is W. So RA is equal to W over sine alpha. Now W is given. That is the sum of the two weights, the weight of the man and the ladder. Now put the value of alpha. So in a scientific calculator, this comes out to be RA is equal to 917.391005 Newton. Then apply sigma x is equal to 0. Now, we have already a force along negative x-axis, that is RB. So there has to be a force along positive x-axis and exactly equal to RB to cancel its effects. And what is that force? If you drop a perpendicular from here, this length, from here to here, this from here to here, in this triangle, by taking cos alpha and cross multiplying, you get this length as RA cos alpha. So RA cos alpha is along positive x-axis, RB is along negative x-axis, so they are opposite to each other. So if their values are equal, numerical values are equal, means their magnitudes are equal, they will cancel each other's effect. So the condition of equilibrium of sigma x is established. So sigma x is equal to RB is equal to RA cos alpha. Just put the value of RA which you calculated, put the value of alpha which we have also calculated. So this comes out to be 222.5 newtons. So these are two good questions. This is a good question for your JEE main, or if you are preparing for GATE examination. You might get in your medical entrance examination, that is NEET. But in that situation, you will not be given such angles, because a calculator is not allowed. The values will be so nicely given that these angles will come out to be some like 30 degree or 60 degree, because calculators are not allowed. So the values will be so nicely given that you don't require a calculator actually. You need to apply only sigma x is equal to 0 and sigma y is equal to 0. And keep in your mind that the three forces must be concurrent, and the resultant of any two must be equal and opposite to the third one. But doing that way, it will be more time consuming. So you have to split the vector which is making some angle with x-axis or y-axis to its horizontal and vertical components. Then apply sigma x is equal to 0 and sigma y is equal to 0.